Hello guys, welcome to Teach Electronics. In this video session, I will show you what is an SCR, operating principle of SCR and the characteristics of SCR. So let's get started. Now let's see basic structure of SCR. This is the basic structure of SCR and this is the symbol of SCR. Basically, SCR is a 4-layer PNPN device with 3 terminals brought out, namely anode, cathode and the gate. The gate terminal is a controlling terminal that can turn on device whenever required. This is the symbol of SCR. It is the symbol of rectifying diode with a third additional controlling terminal, that is gate. As you can see, there are 3 junctions, junction J1, J2 and junction J3. In order to turn on SCR, the anode must be at a higher positive potential than cathode. That means SCR should be forward biased. Basically, the SCR is unidirectional device and that the gate current can be only positive. The gate current can flow only in one direction, that is into the gate terminal. Now let's see the operation of SCR without gate current. The gate terminal of SCR is left open. So the current through gate is 0, that is Ig is equal to 0. So SCR is forward biased. By applying a positive voltage to anode, as respect to cathode is negative. There are 3 junctions, junction J1, J2 and J3. Out of 3 junctions, junction J1 and J3 is forward biased and junction J2 is reverse biased. Therefore, current does not flow through SCR. The entire applied voltage will come across the junction J2, this junction. Entire applied voltage across the anode and cathode is come across junction J2 because it will reverse bias. Hence, current is not flow through the SCR. As anode to cathode voltage is increased, the voltage across junction J2 is increases. At a certain voltage, this junction will break down and SCR will start conducting. This voltage is called as forward breakdown voltage, VBO. Thus, it is possible to turn on SCR without any gate current by exceeding its value to voltage beyond VBO, that is forward breakdown voltage. Now let's see the VI characteristics of SCR. It is a graph of anode current IA on y-axis and anode to cathode voltage plotted on x-axis as shown in figure. The VI characteristics can be split into 2 parts, namely forward characteristics, this is forward characteristics and this is reverse characteristics. Now let's see forward characteristics. Anode is positive with respect to cathode. Hence SCR is forward biased. The forward characteristics is divided into 3 regions of operation, namely forward blocking state, transition state and on state. This is forward blocking state, this is transition state and this is on state. Forward blocking state. This is the high voltage low current mode of operation in which SCR is in off state. The current through it is forward leakage current. This current flow due to thermally generated minority carriers. Now let's see transition state. SCR remain in blocking state as long as forward anode to cathode voltage is less than breakover voltage. As soon as VAK become greater than breakover value, the anode current I increases sharply to high value and the voltage across SCR reduces sharply to low value. The switching of SCR from off state to on state and vice versa take place in short time. This changeover is called as transition state. As this is an unstable state, it is shown by dotted line here. Now let's see the on state. This is the low voltage high current mode. This is the on state. And this is the holding current. It represents the minimum current that can flow through SCR and still hold it in on state. The voltage associated with the holding current is termed as holding voltage, VH. If the forward anode current is reduced below holding current, SCR will turn off. The holding current is defined for a zero gate current. Ig is equal to 0. It is denoted by IH and its value is few tens of milliampere typically. Now let's see reverse characteristics. For small reverse voltage, a small reverse leakage current flows until a breakdown takes place at reverse breakover voltage VBR. As soon as the reverse breakdown takes place due to breakdown, a large current flow through SCR, whereas the voltage across device remain constant. Hence, it is dangerous to operate SCR in reverse breakdown state because it may damage due to overheating. The region from 0 volts up to VBR volts means 0 volts up to VBR volts, in which SCR is reverse bias and non-conducting is called as river blocking state. Here is it represents the river blocking region. Thanks for watching. Don't forget to like and subscribe. If you have any question in your mind, then free to comment in this video. Thank you again.